The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaiiʻi Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. Still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, a group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I'm geologist Philip Ong, here with Mr. Dane DuPont from Hawaiʻi Tracker and HVERI, the Hawaiian Volcano Education and Resilience Institute, as well as the Kaufmans here, our ASL interpreters, joining us once again. We really appreciate them making our show more accessible. How are you doing today, Dane?
Doing good, doing good. How about yourself?
I'm doing all right. We've been up around looking at the volcano, talking story with lots of people. The volcano is still erupting, lots of lava out of the ground. And we're here to recap the first 24 hours is where we are. The eruption may go on for who knows how long, and we'll keep going as time goes on here. But today, just the first 24 hours. Right. How has that been for you, this first 24?
Been a lot going on. I mean, one of the big things that I was trying to, pull for was that lava fountain, to be able to walk to that outer wall of the down drop block and be able to climb it, because that would have just been a great show. But it doesn't look like that is in the cards at this point. We'll be going through a whole bunch of other stuff as well. But yeah, right now you're looking at basically the most vigorous part of the eruption.
Sounds good. So should we go through it here? And
yeah, let's go ahead and get it going. If you got any questions, anything like that, go ahead and drop them in the chat. We'll try and get to them at the end.
All right. So let's rearrange the screen here, first of all. And let's put our summary tag here along the bottom. And let's share with you guys our Hawaiian volcano summary for the first part of this week is that Kilauea has been erupting for over 24 hours now. The eruption began with much vigor and lots of lava floating across most of the crater floor, as well as the downdrop block area, which was previously not covered by lava recently. The activity has focused from its original length of 0.8 miles. It's shrunk down to something less than that, and that center area is what you see on screen here, the most intense area of fountaining with multiple large fountains there that are now forming spatter cones, spatter and cinder cones on their perimeters, as you see on the screen here. Otherwise, the eruption is still going pretty strong. The gas output is intense. The USGS reports that their preliminary measurements indicate up to 100,000 tons of SO2 or more. And so we await some final measurements from the USGS on the gas and volume and eruption rate from their work that was done in the field today. So in summary, the eruption remains contained within Kilauea summit, very spectacular and worth trying to see. And lava is not moving into any of the rift zones, and there is no threat to communities on the volcano at this time. I'll throw in one quick question I got. People have been asking how likely it is for lava to reoccupy the rift zone. And as a short summary, the rift zone is less active today than it has been at any previous point since the 2018 eruption. So signs look promising that it will still be some time before that happens. So be reassured, the biggest impact of this eruption is still the massive amount of fog, which is blowing downwind Kau, South Kona, and other leeward areas of Hawaii Island. And otherwise, it's a fantastic show and the caldera of Kilauea that we'll cover in detail here in our larger update. So that's our Hawaiian volcano summary for the week, for this first half of the week, I should say, since we are cutting in extra additional programming today. So yeah, that's what you see here on the screen is that intense fountaining from that center spot, and we'll talk through this, but just to start us off with a summary here before I get into some of the details, I'll add this to our summary, and this is a time-lapse from the KW camera for the last 24 hours, showing that outburst on the far side of the crater, and lava covering the crater floor. Not entirely, there's a section over here on the right, which is that basin from the most recent June eruption, which has not been filled. A little bit down in here, you can tell, but mostly not. And a high spot in the middle that hasn't been covered as well. But if you consider that this whole area up here is also now covered and it wasn't prior, then the total area of eruption is similar to what we saw in June as well. I know we want to see lots of the great imagery here, but I thought I really should start off today with talking about our hazard, which, as I've been repeating myself, is the gas here. So let me put the gas data here on screen. And just to mention, this is coming from VMAP, the Log Measurement and Prediction Project from University of Hawaii, Manoa. And the forecast, I don't believe it's been updated. Let me give it a reload just in case here. So yeah, our value is still not putting out the true 100,000 tons-ish per day, but it is telling us the direction that the fog is dispersing by this dark color coming off in this direction here. It might be a little hard to see. I'll zoom it in a little bit here. See, largely it's this area of south of Kilauea, around Pahala, Na'alehu, South Point, all the way through South Kona. It looks up into Kailua Kona itself. And actually, if you look at this map, there is some as far as this Waikoloa area as well. So that's the actual forecast. When we show this later in the week, I expect that this value will be changed, and we'll see a lot more orange and red on this graph as that forecast matches up. For now, all we have is written here behind our logo. It actually says Kilauea is currently erupting. Therefore, air conditions may change, air quality may change quickly beyond this forecast. So to look at the actual real-time air quality, let's go to purple air. Let's load this up here and hope for the best. And there it is, our map of the island. One thing that we saw yesterday before the fog cloud started dispersing was everything was in the green. And here we are 24 hours later, seeing these values of yellows and oranges all down this Kona coast, all through here. And so it's actually surprisingly low in Pahala at present, But if I click on that sensor, you can see that in the past 24 hours, there have been a couple of peaks into the yellow and then one into the orange as well in that area. So it can be variable, but intense depending on exactly what the wind is doing there. Right. Just for another example, here's Kīlauea Kona. And you see it had a spike. It looked like, well, that was not to do with the volcano. It was prior to the eruption here. And really, since the eruption, you can see the wind dispersing this fog around the corner. And here it's climbing, climbing, climbing into the yellow, having spiked into the orange and even the red earlier today around noon or so. So this is the most intense effect, is the gas. Otherwise, the lava is not a threat, and it's something people are coming to actually see. Interestingly, the fog is mostly blowing up and away from the national park. So let's see if I can make this bigger potentially here. This is the air quality map from the national park showing SO2 and particulate matter readings at different parts of the national park every 15 minutes or every hour. And that's either green for a measurement within acceptable range, or you'll occasionally see something that's more in orange or the red. So here we have over at Kahuku Cross Fence area, which is over in the South Mauna Loa area, not in the main part of the park, but the separate section. You can see that area is recording elevated SO2. But everywhere else in the park, including the main visitor center, the steam vents overlook, the lava tube area, everything has been in the green all day. There is a caveat that we'll get here in a minute, that one of the overlooks has been closed as a result of this. But to dive into the SO2 a little bit more, here is the live data from the national park showing their current weather and air quality. And all I've done here is pull up their graph for the last 7 days for SO2 here at the visitor center. So we are actually, eruption started right in here, and this is all not recording any SO2 whatsoever at the visitor center. There was one spike that occurred last week on the 5th, in fact, when the volcano was still in its background emission stage. And to understand what happened there, I'm going to scroll down a little bit more to show you wind direction at the visitor center. So all through here, this is our regular trade winds coming from the northeast, 45 degrees east of north. But occasionally we have the winds slacken and come from the other direction, from the Kona side. That's what you're seeing over here. So this was Kona winds. Yeah, at the same time as we see this SO2 spike. And lastly, that often corresponds with slower wind speeds. So here's a wind speed at the national park in miles per hour over the last week. And about a week ago, you see that the wind speeds were all below 6 miles an hour. So very weak and coming from the Kona direction. When the trades come back in, that picks up to this 8 to 15 range here. And then the fog seems to blow away from the viewing areas off across the desert towards the southwest. The one caveat to that is when we get to the viewing, we'll talk about this next. Let's roll right into our lava viewing report here and show you this map. So our eruption site in this map now actually spans all the way from here and down, and then this whole bowl as well, something like that. So most of this gas is blown off in that direction. However, you might notice how close this overlook, Kīlauea overlook, is right here to this eruption site right here. So it's right above it. So in fact, yesterday, the gas was blowing towards this area, sufficiently causing concern that the rangers could not evacuate people in time, because this is the one that requires a 1 mile hike in and then 1 mile hike out. So that area has been closed as a precaution because of that potential of the wind changing and very quickly bringing that fog to a close by overlook there. So that's something we'll have to check with the park probably on a daily basis if you're going to go up to look at the viewing. Otherwise, the best viewing is up here in the north side of the crater from Uekahuna over to Kilauea Overlook and a little bit further to the east as well. Right in there is the area. The reason being that this cliff of the downdrop block right in here obscures much of the view from the direction from the east. So you don't see much of what's happening in the foreground. Maybe you can see a little bit of the spatter. The other things from that angle, you can see very well this backside of the innermost pit. And that's actually the one area not covered in lava from a recent outburst. So that has meant the views from this volcano house area and further down over here have not been as good until you get back around to the Kīlauea side. So by and large, most people are crowding into this area here from Steaming Bluff over past the KMC, Kilauea Overlook, all the way to Uikahuna, former Jagger Museum site, all through there. Right? And that's created some traffic delays and backups, as is typical when we have the first few days of fantastic viewing at the national park. So if you're looking at where to go, here's your answer. It's somewhere up in here. You may be forced to park who knows exactly where, and then walk to where you can from wherever you're able to park, is how it's going. Rangers are directing traffic. They'll direct you to a particular parking lot, whether you want to or not, and that's where you start your hike from to wherever you want to end up going. In my experience yesterday is what I can share. So that's the map and how things look. So we'll move on from here to, where's my other eruption viewing information? Here we have a press release from the national park. As usually occurs when eruptions begin, they encourage safe and respectful eruption viewing. And there are lots of recommendations. This is all on the national park website if you're curious to go and make sure that you're visiting respectfully. They do note that they're hazardous and can change at any time. Stay on marked trails and overlooks. Do not enter closed areas. Avoid cliff edges and earth cracks. They are unstable. And just to reemphasize, if people are walking out there in the dark, be extra careful, right? And if you're too close to a cliff and there is suddenly some earthquake, then you don't have time to react in time. So hazardous volcanic gases could be a danger to everyone, especially people with heart and respiratory problems, infants, young children, and pregnant women. They ask that people observe the eruption quietly and respect Native Hawaiian culture practitioners who honor the sacred legacy of this land and give them space to practice their customs. Also, good advice, slow down and drive safely. Expect people to stop unexpectedly because people are walking the road or not on a trail, or there's just a lot of extra activity around the park, and not everyone knows where they're going, or they might stop or do something unpredictable there. They do note the Kīlauea viewing area is closed due to high concentrations of SO2, noting that rate of up to 100,000 tons. Then they do say it will remain closed until it is safe to reopen. So that's why you'll have to ask to see when they deem that to be the case. They note optimal viewing in Lava Lake and fountains is available at Uikahuna, Kilauea Overlook, and areas along Crater Rim Trail as of Monday afternoon. Conditions can change at any time. So that's what we just shared on a map. And they do note there's also a temporary flight restriction above the caldera of 1,500 feet above ground level for those of you looking for air tours. No threat to homes or the community at this time. So we're all consistent. Everyone is saying the same thing. It says just the way to prepare yourself for traffic. You want to make sure you have flashlights. You want to have water. There's a whole other part of the national park website that describes all these recommendations in great detail that you can check out as well. So there's that. I did want to show you guys, there is a web camera the national park has installed at the volcano house that is to monitor for fog. Now it also does pick up regular fog and rain and all of that, but I thought I would play for you here. This is from the beginning of the eruption, what was visible from Volcano House. So mostly you see a bunch of dark. The lava is actually in this pit over here. So let me give that a zoom in, give you a chance to see it. There you see the first burst of fountain was actually visible in front of this cliff right here for a short while. And then it drops back down and you see just the edge of the lava lake. And you see it just all through here. And just a little bit, there is an arm that goes off in this direction that stalled off early, but most of it's behind this cliff over here and behind this cliff over here. So this is just an illustration of why the volcano house may not be the best viewpoint unless conditions change based on this camera that the national park shares. So there's that. We'll share some of the other views that the public has captured, USGS has captured as well a little later on. But I would just mention while we're here talking about viewing that if you're not on an island and not able to come, check out Two Pineapples on YouTube. Our partners, collaborators have been monitoring. They have a monitoring 22/6 feed running all the time, but they're also streaming live. They were up there this morning for 4 hours. They were up last night for a similar amount of time as well. Dane called in yesterday. Dane, you want to jump in here and give us a little summary of how that's been going? the live streaming with Two Pineapples?
Yeah, just jumping in there. They have a whole bunch of questions and viewers that come in that aren't as maybe familiar as our viewer base here, or even the normal viewer base on the Two Pineapples channel. It's always just a madhouse when the eruption happens and the live stream gets started on that day one. So you get hundreds and hundreds of new people in there, and they have a lot of questions that we've probably answered 100 times each. You probably answered 1,000, but it's good to go through the basics and then try and give a little bit of insight as well. Because people, it's hard to gauge things unless you experienced it, right? With like the SO2 type of thing. So we were talking about that a little bit. And one of the things was, you don't need to go into the SO2 this time. It's kind of like the Mauna Loa eruption. You didn't need to go and experience the SO2. This isn't 2018 where you had no choice and you just had to deal with it. I mean, it's a night and day difference. So really, I mean, if you smell fog, it's not that big of a deal. Really, in general, the biggest thing that I feel first, I don't know about yourself, if you are getting like the fog's getting heavy type of thing, is that tickle in the back of your throat, right? When you get that, it's like, okay, the ppm's about to go up or is going up. I need to get out of here right now, or else it's about to get ugly. But they did close it last night, right? And that's probably smart because just how much resources are strained up there on those night ones, because it is just on the stream, on Two Pineapple stream up at the park is a madhouse. It's just so many people want to get in there on day one and get that shot and see that fountain. So they're up. The park rangers are doing everything they can, and sometimes they just have to make a call like that, right? Like, we got to close it down. Precautionary.
Yeah, and that's the south side. Yeah, and so on the north side, it's really not much to worry about. The fog is hardly ever there, and there are rangers roaming just about everywhere that I saw. One good thing about the lava viewing area being somewhat contained on one side of the crater and everyone being in one place is they can actually circulate much more easily among everybody in one area in this as well. So that's a lava viewing report. Check out Two Pineapples if you're not able to. Otherwise, check out the park and the National Park website for more information. So now we'll keep it moving because we have a lot to get through, and we'll pivot here to our live monitoring segment of the program and just summarize some of the USGS notices that have come out. So starting off, just to recap, the eruption announcement was at 3:18 yesterday, September 10th. And then moving from there to the update that occurred last night after our update, 7:20 p.m. They did note the volcano was still erupting. They noted the line of fissures stretches approximately 0.8 miles, 1.4 kilometers from the eastern part of Haleʻiʻamaʻu crater floor, extending into the east wall of the downdrop block. Lava fountains have decreased since eruption onset, but remain up to about 20 to 25 meters, 65 to 82 feet high. So for those of you asking how high are those fountains, this is the best answer for yesterday, and they may have come down a little bit since then for today, and we'll see some updated captions further ahead in our show here. They do note the things we mentioned yesterday as well. The laser rangefinders aimed at a western portion of the crater floor, not near the new activity, recorded less than 1 meter of new lava added to the portion of the floor. An estimate of effusion rate will be provided after an overflight of the new eruption site in the morning that occurred this morning today. They do note the summit switching from inflation to deflation, earthquake activity greatly diminished, replaced by continuous eruptive tremor. They do note that they measured yesterday between 4 and 5 p.m. the SO2 rate, and the preliminary emission rates are, quote, of up to 100,000 tons per day or more. Not to give them a hard time, but up to or more is, the ballpark 100,000, more or less. We'll wait for the final number. Yep. So that was the update from last night. There was a couple releases today. The first one was another one of these volcanic activity notices, VANs. And now we are downgrading from warning to watch and from red to orange, right? We're downgrading from red to orange. The reason being because the style of eruption and fissure location have stabilized, the initial extremely high fusion rates have declined, and no infrastructure is threatened. Yeah, so they are thus not worried about significant volcanic ash emission into the atmosphere outside of the closed area. They do note the eruption plume, composed largely of SO2 and minor volcanic particles, continues to rise to the base of the immersion level at about 8,000 to 10,000 feet above sea level. They note that concentration has decreased due to the drop in diffusion rate, but still remains high. And ongoing for lots of the hazards, which I won't read in any further detail in there. So just to show you guys what information is being put out in different formats here, this is the one that's geared more for the managers and aircraft controllers as well. We do have an update from this morning as well that was put out just before 9 a.m. And that notes a few other things here. They have not updated this 0.8 miles, even though we can visually see that the extent of fissures has shrunk. We'll get to that in the time lapses here shortly. They do note that the lava fountains have decreased, remain up to 10 to 15 meters, 32 to 50 feet high this morning. So that's the most recent value we have. They do note lava erupted on a downdrop block is flowing westward back towards Highland Mountain Mile crater and covering much of that surface with active lava. Same thing with the rangefinder, same thing with the SO2. And I haven't read this yet, but no unusual activity along either of the rift zones. And there is no extra hazard or gas from the rift zone, including pool. So all good still for people, so long as you're prepared for the gases which might blow into your area. So that is the text updates from the USGS. We can go through some of the signals. Often we look at these signals as clues to what might be happening below ground to give an idea of what the volcano is actually doing. When lava breaks to the surface, it's pretty obvious what it's doing. So these signals are a little bit less crucial to us, but they're still interesting to track. So we can see the 2 days ground tilt at the summit. Prior to the lava breaking out of the ground, the tilt started to sky up, climbed a huge amount of microradians. A microradian is a small fraction of an angle, right? So you have degrees and radians, and you're looking at like a microdegree or like a microradian. It's not exactly the same, but to simplify it for you guys, some very small inclination. We often say that if you had a half-mile long, 1 kilometer long bar of steel, for example, and you had a coin like a penny under one end of it, that amount of inclination is about 1 microradian. So very, very small measurements. Our instruments are so sensitive that they can pick up the ground being weighed down by the weight of a heavy rain sometimes. There are tidal effects that can be affecting these instruments as well. The scientists try to filter as much as possible, but sometimes there are multiple signals on there. So that's a little intro for those of you guys joining us on a tilt segment for the first time, perhaps. So as the magma was coming to the surface, the ground above it was bulging upwards. You see the actual ground tilting away from the center. And then once it actually pops, then those edges sag back in. And that's what we're seeing here for the last 24 hours. Is this typical long decline of tilt back to its close to its original level pre-burst, pre-eruption. So there it is in the 2-day time scale. On a 1-week time scale, here's what it looks like. It's all compressed. We had some wiggles as the pressure was building beforehand and a week ahead. And the lava depth, as we've noted a couple of times now, is on the other side of the crater, not in the main segment. So in that far part of the crater that's only getting a far lapse of lava and perhaps is experiencing rising of the crater floor from below. We don't know that's the case yet, but that's possible as well. More on that in a minute. Altogether, we're looking at from 400.5 meters elevation to 403-ish. So now we're looking at 2.5 meters. That's closer to 7 feet or so of rise of the ground compared to where the laser is on the rim of the crater there. So earthquakes for the last week. Here is our most recent day. It's dropped off to very few earthquakes. That's as expected. One thing that happens is as a magma is pressurizing to come out, it's pushing against all the different parts of the reservoir system, and there can be earthquakes all over the place everywhere. Once you create a relief valve, then all the quakes essentially disappear because all the pressure that would be causing an earthquake is directing the magma upwards and out into the eruption. So that's typically what you see. And instead of having discrete events of the ground quaking here or there, you see what we've called tremor, which is the vibration of the ground as the magma is flowing out through that conduit to the surface. So that's the earthquakes. We can see that similar pattern here. And this is earthquakes also for the last week, but now we're plotting depth against this last week. So these shallow ones plotted in orange and red are the ones that are that shallow system by the magma. And here you can see a pretty dramatic cutoff in those events near surface. Deep events still ongoing. Down in Pahala, the feeder source is unaffected directly by this surface activity. Here it is for the last month, where we've crashed down to, it looks like very few, it's hard to tell exactly, maybe less than 10 earthquakes per day here from what yesterday was close to 150 across all of Kilauea. And there is lava depth for the last month showing this similar rise. We'll come back to this in future updates once we know exactly the orientation of the laser and the depth elsewhere. So for the last month, here's our pattern: tilt up, tilt down. Likewise at the Sand Hill Station, which we noted had both a direction towards the main summit area and this extra reservoir to the south that was inflating, swelling much more rapidly in this last week, which really gave us pause. They're both now deflating, right? So you see both those areas feeding pressure into the eruption. At the East Rift Zone by Pu'o'o, it's the opposite pattern. It's still one of deflation, of sagging, and just one more time to reconfirm that there is no magma going towards people in the lower East Rift. Okay, we still don't have that newest SO2 measurement, but when it does, you can expect all these plots here, all these dots are going to all look like they're at 0, 0, 0, 0, and our scale here is going to be a lot larger. Here we see 90 is our maximum value. More likely, we'll get to something where it's 100,000, 150,000, something like that. So lacking the integrated measurement across the whole volcano, we look at these spot measurements at different places. Here's one at Sand Hill showing ppm of SO2 spiking to close to 10 ppm just today here as the winds blow in that direction more so. Here's our Cone Peak Station, which is also in the Southwest Rift. It has not spiked nearly as high. You can see we're still under 1 ppm at that station, so it can be quite localized where the gas blows. And one more station here showing, in this case, 2 to 3 ppm of SO2. And this is a good support for why that overlook is closed. If the wind does blow into an area, it can escalate pretty quickly to high levels of SO2. Here's our year-long plot of gas showing that larger scale. Here's 80,000 tons per day. That was our June measurement, was close to 80,000, maybe 75,000 tons per day. So this one appears to be exceeding it. We discussed how the last eruption was a very gassy one, and it appears that this one seems to be following the same pattern, which once again makes this June eruption our most relevant eruption in our model for what we expect to happen next year. We've had the questions, and there's impossible to answer. How long will this thing last? Best guess, same as the last eruption, similar to the last eruption. So if this were Vegas, I'd set the line at the last eruption was 11 days. I'd put it at that. Just, you know, that's what we saw most recently. This eruption may be possibly even faster. We'll see. So moving on, we're still looking at the 1 year long plots. Here's earthquakes once again, same pattern, showing the drop in earthquakes this week here. It's going to end up being much less. For the whole year, you can see our 3 eruptions. Here's when we have the prequel to what we have now. This is prequel to June, and this is a prequel to January, right? And what I found fascinating looking at this now that things have settled out is that the volcanoes seem to require more earthquakes each time to actually lead to an eruption, right? So our levels here are, we actually can draw a line from the tops of these things and say, okay, the actual threshold for it to break has been increasing over time. And part of that, the way I think of it, is we have magma injecting into the entire magma reservoir within a caldera area in the summit. And it's reinforcing and filling little cracks and strengthening that whole thing by just pressurizing and filling it with more material, as opposed to what we had prior, the 2018 after effects where there's lots of cracks and void space in that rubble that's fallen down to the ground. So that is the earthquake counts. GPS, we don't have the most recent data. These are instruments that only put one dot on its plot per day. So we're missing a few days here. It's likely that that something went offline as far as plotting this online. We often see these refilled once the issue is solved. But this is something, once again, that we expected to see. A pattern would be something like this. So the last eruption that we had in June, we saw similar to the tilt. It goes up, and then it kind of comes back down like that. Before at some point, you see it turn back around, and the magma coming into the volcano at depth is no longer all leaving the volcano at the top. And so that's one crucial point that we look for as eruption goes through its first week, usually, of when it will turn around. And we'll have to wait to see what that looks like, both on the tilt and the GPS here. And unfortunately, we also have data missing from the rift zone at Pu'o'o, but we see the tilt is still what we expect, so no big deal there. Okay, those are the earthquake maps for the last week. For the last month, we showed these yesterday as well, just to recap what got us to this point in time. And with that, we will go to the earthquake map itself. So let's pull that up on here and just show you guys the earthquake map. I have on here plotted earthquakes for the last 24 hours. There appear to be 11 on the whole island, most of them down in Pahala, one up here in Mauna Kea, a couple of settling ones in this area here. So let's see what we got. Here offshore, that's 18 miles deep. That's one of those deep Pahala or settling earthquakes offshore. This one, 19 miles deep also. That's part of that conduit, right? So these deep earthquakes in Pahala are thought to connect to Kilauea's magma supply system in this direction, more or less. So seeing deep earthquakes in that direction is not surprising. And one last one to look at here. That one's at 2 miles down and 2.6 down here on the edge of the Kō'ae fault zone, which is these set of faults that go this direction, and the southwest rift connector right through here, right? Only 2 miles down. That seems to be more related to what we were seeing with the adjustment post-eruption onset. If I change my settings here, let's put it back to the last 7 days so you can see some of this other pattern in here, right? All this activity of earthquakes in here is all related to the swelling of this storage area just southwest of the summit connected to the summit caldera. It seems like it could potentially be that South Caldera Reservoir, which we know is down in an area right through here underground. But we also have reports of inflation in 2006 in a larger shallow area all through here as well. And as that area fills, it kind of pushes to the side, and that seems to be the point it catches. Either way, whichever way this thing is pushing, that seems to be where the earthquakes kind of flare. It's like maybe, you know, think of it as like maybe an arthritic knee or something. It's the spot where the volcano feels it when things are pushing and pressurizing and it's under stress. So if I come here, I have this by newest first sorted. So that one is the most recent one that actually occurred today, the only one today. If we go back in time, the next most recent one was this one, 2.8. Let's see, it doesn't show me quite exactly. I think it's buried in here somewhere under a more recent one. But that one was yesterday at 4:18 p.m. and 4:14 p.m. were the last two that we had. So really the eruption begins, the sequence begins back here after these magnitude 3s we talked about yesterday. And most activity on a volcano ends by 3:45 p.m. So since then, only 3 earthquakes. There's this one. So let's see if it'll, oh yeah, there it is right there. That one right there. That was only ½ mile deep. This one was actually above sea level, down all the way down in here. And then finally the one over here. Right? So this one and this one are not too different. And you can imagine this being the sagging of this whole Kō'ae fault zone, right? So we've discussed how the whole caldera is swelling. It puts pressure in all directions, right, including to the south. And this wedge of land over here, right there, that one, is this Kō'ae block. The Kō'ae fault zone defines it here that connects the East Rift Zone, which has this connector to the southeast, and it bends right there. Right there, there's a big bend in it. So this connects it to the bend in the Southwest Rift Zone. It goes like that. Right? So that's this little block. So if you see relief of pressure back in this direction, I'm not surprised to see any piece of this triangle actually sagging. And one thing that's still notable to me is how few earthquakes we have anywhere on this East Rift connector or East Rift zone at all. And that's where I come off saying that it seems like the East Rift zone is more blocked today than at any point since 2018, post-2018 eruption. So those are the earthquakes. I know we have been going for some time here, and we still have a lot we'd like to share. So I will keep it moving, and we'll go on to our visual observations here. Where is my observations tag? There it is. So we have a whole set of webcams from the USGS. Let me reload this to get it most recent. Here's our Summit webcam page, and just to show what's happening right now, there's a KW camera, the vents in the background, lava wrapping around here, and got as far as there. We'll look at that in a minute. The thermal camera is picking up a lot of this activity as well. There it is. We have the V1 camera, the live feed, which is being repositioned and reoriented. Sometimes it pans around, but here is that view that we started off sharing with you guys. These cones forming around this cluster of fountains. The S1 camera in the south is picking up mostly VOG, to be honest. The eruption is mostly off the screen to the side here, but depending on these flows that are coming across the caldera floor, the crater floor, the inner crater floor here, those will light up at night, as we'll see in our time lapses as well. So there is a new camera. The S2 camera has been deployed by the USGS on the north rim of the downdrop block, looking west. Here is its current view. And so there is the actual cliff. At the bottom of this cliff is where that other vent is, probably more in that direction over there. And so that's what it looks like from the ground on that cliff there. Further over, where we got now, B1 camera. So the one that was moved back. Massive gas obscuring the sunset. It looks really orange up in there for that reason. It's pretty striking. And the B2 camera is shifted off to the side, but it also is picking up these large flows coming across the caldera floor. So everything looks silver, and its foreground all through here is all fresh lava. And once it gets dark, this will be more obvious to note as well on the camera. We still have our other wider cameras. So here is the roof of the old Jagger building. Nice rainbow in effect right now. Pot of gold here at the end of the rainbow, right in that lava, perhaps. But showing you the wider context in case you're curious where all this fits in. Here's a larger caldera floor. All through there, there's Kilauea back in there. And so there's a downdrop block inset. And all inside of here is where this is happening. Another wide angle here. And we'll pan it to the view from up on a mountain. Let's see if we can see from up on Mauna Loa. You see a little bit of the Kīlauea gas cloud coming through all the other regular trade wind clouds that are also in the area. So that's the current state of what we have. I do want to share in a little bit more detail these webcam time lapses. So starting off with the KW camera. So here it is. You might note how on the south side, the flow only goes part way. On the north side, it actually comes a good amount. Here, let's make this loop for you guys. And you maybe can pick out the edge of this basin that was this southwest vent basin from June of this year. Lava's actually got as far as to pour into that from this arm. Most of this mass you can see here in the time lapse is actually moving all through here. So this is a big bulk of it. Right there, that's the largest part right there going this direction. And then some smaller amount seems to be going over here, and this seems to be dying off more so. There's all kinds of interesting things to look at, but to try to keep it brief and point out a few things. One is that the flow of lava right through here, let's see if I can get this zoomed in for you guys a little bit. You start to see a little bit of islands sticking back up through here. So it's once again a situation where the lava seems to have flooded up and over these features where they're completely buried at this point in time of the time lapse. And as the night turns to dawn, you see these bits of island reemerge through that new crust of lava. So it seems like, once again, like a flash flood came and swept through the area, very gassy initial flow. Then it flows downhill, it kind of settles, gas escapes, and you may have some of these chunks reemerge through the flow there. So this giving you a little bit of the idea of the lay of the land here on the ground as well. One thing we mentioned in June was how after that eruption was over, we saw the crater floor seemed like it was unlevel, and we saw ooze up flows from the far side where we're now seeing fountains. And it seemed to us at the time, and USGS then confirmed it through the reports, that the crater was in fact tilted, bulged up near the southwest vent eruption site. And that was always hard to see because there's so much texture on the floor of this crater. But now that we have this big liquid poured into it, we can see exactly what was level, right? So clearly this is our high spot right over here, and moving over here towards our southwest vent that was active in June. So even though this is a little basin inset in the ground here, that whole piece of land was tilted upwards because the eruption was coming up on one side of the crater and not the other. And so then it was pushing up that side more so. Today it's the opposite. So we'll see if we'll re-equilibrate. The difference here is that we have much more lava erupting on the edge of the downdrop block and not coming through the lake from before. And the reason I bring this up, I hinted at it here previously with our lava depth measurement. In our previous eruptions, we've seen lava come up from below this crusted crater floor and lift the entire plug. The whole thing will pop upwards as one and just start floating up and up and up and up. So that's something that can happen if lava is injecting below that crust and feeding the lava that's still liquid underneath there, because it takes a long time to become all the way solid, especially when it has such a large thickness to it. It'll probably take decades or centuries, depending on how thick that thing is by now, for it to harden all the way. So it can inject under there and then lift the whole thing up, and that might be one way the crater floor can rise, besides lava flowing on top of it. So that can get a little confusing as well. That's our KW camera. Let me keep it moving a little faster if I can help it here. This is the VI camera. This is a similar feed as the live feed. I've just fast forwarded it and basically try to compile some of the like segments together here. And I just loop through the last 24 hours with a few camera switches here. So here's yesterday. You see that initial line of fountains on the downdrop block over there in the west. Here is that eastern bit. Maybe pause this and do it by segment, right? So, okay, here's that first segment showing our line of fissures. And one thing that I've been saying is there's actually a double line of fissures here, and it's not as easy to show unless I draw it for you. So I'll try to do that here. So this is the early on phase of the eruption to kind of start off, right? One thing I want to point out is right in here. This fountain right here is right at an intersection. It's got a line that kind of goes off in this direction over here, but it's got a second line coming across right there. Right? This is the really interesting feature right here. And if I zoom it back out, maybe you can tell that's that old edge of the crater. So here's the actual wall of the crater. It wraps around like this. Right? We had a question yesterday, in fact, from Andre with a two pineapples ohana asking about the 1982 fissure. I had it wrong yesterday. I was misoriented. Looking more closely now, it's pretty obvious. That is it right here. This is the 82 fissure. This little island of land that survives here. Yeah, it's a little bit of a high ground. So in this early part of the eruption, you see it's got these wings around this ridge in the middle. It's almost like a little butterfly in a sense here. As time goes on, everything gets buried except for the spine of it right in here that sticks above the lava the most. But early on, we see this is that kind of right at the edge of the crater fountain, and we have a series of fountains, and we have one big one within the actual lava lake itself that existed in the past. This is the big one right here. That one gets really big, we'll note in the video coming up. But just to note, that's the line. It goes from there. It goes off like this to here. If I keep drawing this line kind of straight, I'd end up over there. So that's not right, because what actually happens is we get to here and we step across and come back like this. Like that's our pattern. It's like a lightning bolt, kind of, right? There's some torque to the direction this thing wants to break, but the ground has got pre-existing weaknesses and it wants to crack in this direction like this, and not in this direction. So it does it by going like that and then making a little connector and coming across, right? So we noted already that this line of fountains coming across at the edge matches the crater wall. That crater wall is a result of the collapse of the caldera in 2018. And it's not the only crack in that orientation. That's things like a giant bullseye where it collapsed most in the middle, but there are cracks going out periodically all the way out. So it seems like this little jog that occurs right here is in fact another one of these cracks. So you see there's actually a collapse crack there, and the last one is back here. It's this cliff over here, right? So 3 series of collapse cracks. So I find it really interesting to see that the fissure then has the shape of, it's got this long line, but then it has this cross that goes across over here, right? And then it keeps going this way, like that. Then it crosses again, like this. And it goes up this way again. And actually, once you get up to here, it seems to cross up to there, and you have this other flow at the very, very top that seems to connect here. So when they say that that fissure has reached into the wall of the down drop block, that's what they mean. This crack has gone all the way into this, intersected this one, and is actually oozing up 2 places, having occupied that gap. Right, so it's pretty scribbly on here. I would maybe do it one more time, maybe more simply. There is the main line, again to there, kind of like that, with an extra little jog in here as well. So hopefully that makes sense. It probably makes more sense to the geologists who know that this pattern of cracking is very typical, and the jargon is called en echelon faulting, where you have this offsets stepping in a similar direction. But that's enough for me to share on that, just to tease the geo nerds out there. Okay, so we've kind of laid out the lay of the land here, and let me advance this a little more. And to start off, keep your eye on this fountain right over here. So there it is. And it drops down to almost nothing, disappears. So that's the first one to go right there. However, note that if I pull this all the way back to when this fountain is the greatest, right here, the vent in the background is actually fairly small. Let's see how much I can zoom that in for you guys. There it is, just at the very bottom of this cliff and pile of rubble. If I then advance this to where that fountain in the bottom right comes down to there. Yeah, so it's still here, still present, but reduced dramatically at the same time as we see this vent become more productive at the same time. So the flux, the amount of lava coming out, is migrating in that direction, it seemed like yesterday evening. However, by today, the views we see today is that this part has actually shut off, and mostly what's remaining is all through here. So to continue it forward, here it is. That one dies off. I saw something else I wanted to show, but it went by too fast. Our line that corresponds to the crater edge here also disappears as the output decreases. And you can see right through here, this is the big funnel channel that's draining all the lava from the down-drop block into Haleʻimaumau crater right there. This little wedge right in here. So lava is coming out from all these vents and then very quickly hits this funneling spot to pour into the larger area that we've seen erupting over the last few years. So there's that. Let me pull ahead here. We actually have a camera zooms out, I believe is the first thing that happens. Yeah, so you see the full extent. There's a funnel right there. The full extent of the lava lake. Note that there's a funnel coming from these channels down. Let's make this bigger so you can see. There's a funnel coming from these fountains straight into the lake here. And the second one wraps around over the down-drop block and comes in further to the north. There's a lot of lava coming out. It's coming in every which way it can into this basin. So moving ahead, there is that furthest distal tip. And this camera is basically zooming into the areas that we saw in our previous time-lapse, the Kilauea camera. This is where it's coming over that edge of the lip. And you see there's a little bit of a falls and a new little delta forming at the bottom of that pit there. Right, and there is our southwest vent from a previous eruption. If you're looking for an orientation, it's hard to catch this on any other camera apart from this zoomed in one here, but that gives you some reference to how far across this almost exact opposite end of the crater where the lava is coming out now compared to where it came out a few months ago. So that's our VI camera. And then the last thing here, let's pull it to this last section. So They do tighten the field of view in a camera this morning as eruption seems to have waned in the upper part, not so much lava. We just talked about how further into the old crater, not as much lava. It's really focused here in the middle. So what you can see here, this does jump one time, but what we look for is how these cones are now the feature that's growing overnight and this morning. That's the story of what's happening here. So play it, you see these cones actually rising and growing in shape here. Yeah, collapsing as well. And now it's looped back around here to the beginning. So we'll let it play all the way through. Zoomed in, zoomed out, distal tip, and cones here, all from that one roaming camera that travels all around. So pretty fascinating to see all of that. But let's keep it going here and show you the thermal camera. Thermal camera is not capturing any of the downdrop block. You see here this line between the purple and the orange-ish, where I'm highlighting, is the edge of the crater. So as I play this, you see the initial fountain popping up right there. And you see now the funnel that's leading from a downdrop block into the crater. So let's see, this is looping, so I can actually zoom it in and it'll keep playing here. And show you guys this initial fountain popping up right there through the crater floor. That one dies off, focuses on the wall of the crater, and then to the downdrop block, migrating towards the block over time here at the beginning of the eruption. That's the actual vent area. You can see here the two arms coming around, the one in the south, that seems to be less hot. You see it stalls out, stops moving quite as quickly, where the one in the foreground here is really stealing the show on this animation. Big sheets of lava coming and covering this whole trough around the central high. And here's that edge of that lip where you see these extra open channels pouring in into that basin right through there. Here comes one. Oh, no, right there. The very start parts occurs, and it seems like that is no longer, lava is no longer reaching that pit at present. That's the thermal. I know it's a lot. Let's keep it going here. The B1 camera. This one is on that. It was the one that was moved to the upper edge of the downdrop block. So reverse angle now. So there is the wall of our block. Our line goes, so if I were to try to draw that zigzag again, it goes like that through there. Yeah, it's kind of skewed from here, but that's what we're looking at. And mostly you see a lot of the gas, and you can see some of the fountains popping through the fume as well on this animation too. Reverse angle of the flow wrapping around down towards the west part of the crater there. Okay, I'm not going to show you every single camera, but I'm going to show you one more. This is the S1 camera, the one that's in the south. That's not catching the fountains directly. They're off screen here. But here you see this flow wrapping around and the high area here not getting covered, in fact. Yep. One thing to note, if I can pull it back to the F1 camera here, this patch in the middle that's a little bit darker, this is our western basin. This is a pit that's filled with lava every single eruption thus far, where it's existed right through here. And it appears that lava is not refilling that area, so it has not found a path through the crust below through here. Right? So as we discussed, is it possible the lava is coming below this crust and raising it upwards? We don't see evidence for that recently right now. I've got to rewind it to our KW camera once again and zoom it way up in here. And I wonder if this is the best view or not, but the initial fountain pops up right through there. Then you actually have an upwelling pop up right through here off to the side. And right here at the edge of the old central island, you do see a little bit of lava popping up here as well, but that seems to be only that first phase, and we don't see it quite as much since then. So that's still an open question to me, looking for more clues of where the lava is getting underneath this crust and lifting it upwards or not. If we were to see it pop out here in the middle of this pit right here, then you could easily tell if that was the case, but we're still waiting to see what happens there. We mentioned the new S2 camera. Here is a view from earlier, looking straight down that fissure line. And we do have some other captures. So the USGS put this out today. This is from their B1 camera, which they actually have a live feed to the observatory. On the webcams, we only get an update every few minutes, whether it's 5 or 10 or 15. But they actually have this running all the time. And so they're able to extract this clip of video from it of the actual beginning of the eruption here. Let me put it back to the beginning so you can see more properly. So this is the unaltered USGS webcam video. Mauna Loa in the background. There comes the fountain in the foreground with a lot of gas coming along with it as well. This is in real time. So it's pretty small. What I thought I would do, and I'll just pause it here to expedite us along, is crop that much more zoomed in here. So here it is. There is that area that began putting out quite a lot more gas. Look at the gas cloud here, wispy back here, and then really dense. The fountain pops up, just bursts right through. It's immediately several tens of meters high, it appears. And this angle, I believe, will get cut off fairly quickly, but you see this first phase of it bursting through in that initial fountain, and the gas coming through. So there's that. There was a comment that was on Twitter that Dane pulled from there. Someone asked, what's the height of the fountain? And Yes just replies, we estimated it to be in the neighborhood of 50 meters. It's about 165 feet, more or less. That's that initial burst shown in that video, presumably. That fountain, I believe, gets bigger later on, so I'm curious whether we actually got to, say, 200 feet or higher than that, perhaps, as well. We'll have to await further information for that. Okay, so there's another video Yosh just put out, which was this one. This is now from the, I believe, the S2 camera. No, it's not this is a new one. It's the B2 camera, right? This new camera that's been put on a lip. And so you see wispy gas, more intense gas coming up. And the eruption is going to pop up right there, bursting through the ground and shooting high. Now I realize this is only one small piece of your screen once again, so let's just pause this and just do the same thing again. Let's blow it up and zoom it in as much as can. It's still on the very edge of the screen, but at least can be a little bigger for us here. So here comes our puff of more intense gas. And now I can probably zoom it in even further, and you can maybe see these chunks of rock getting flung into the air when a lava bursts through any second. Right around now. There it goes. That initial burst, pretty impressive right there. And then I'll zoom it out, which maybe you can see if I were to take this and fast forward it a little bit, is we start to see lava flow emerging at the base of this thing. There it is right there. It starts to creep across the crater floor. That's all we can see from this side of the camera, as all these big chunks of lava start falling off to the side as well. So I'll advance it a little further. Flows a little further on, creeping along. Let's put it a little further even, creeping along a little more. And you can see the fountain just growing in height, higher and higher and higher and higher there. And so that's how the onset looked here. This is not something that we had caught in webcams initially until we had the USGS release this real-time versions of this of these captures here. So mahalo to them for all of that. Other videos released by the USGS today include this fantastic one, which does include sound. I don't think the sound is going to come through for you guys today, but if you're curious, you can go and find this posted on Hawaiʻi Tracker as well. So let me play this for you guys. What happened, in fact, as land off to the left here, if you can hear sound, you actually can hear the helicopter's blades spinning still. They didn't turn it off. They're waiting to just load up and get out of there. The geologist has found a spot where he can stand on solid ground, but actually access the interior of a new flow. He's bringing that flow over to a metal bucket here, and he wants to cool it as quickly as possible, because what he's really looking for is the crystals that have grown in the lava over the life of the lava coming to the surface. And the slower the lava cools, the more crystals it'll grow. So what he's trying to do is cool it off immediately, so the only crystals in there are the ones that grew in the lava and transport to the top of the volcano. And so they'll take that, measure it, crush it up, analyze all the chemistry of it, and that'll tell us more about how deep the lava is coming from, how long it's been sitting underground, what other lavas it may have mixed with that may have come to the surface before, that kind of thing. That's where they're coming from that. So I thought it was pretty interesting stuff. And I played again, apart from we're going so long, here is the last USGS video to share with you guys. They're zoomed into this fountain that's creating this cone as early as last night. So this is all within the actual crater. This line right here on the bottom left, that's the edge of the crater rim right there. Here's our big funnel pouring lava into the pit. And so the largest fountain, the one that opened it up, was off screen to the right here. And there's a lot more stuff uphill to the left. We also can see they're really zoomed in on this little intersection point, which was quite vigorous last night, as you can tell here. So I'll advance it as well, because it's going to give you some idea of how it moves along here without having to take the full 3 minutes of your time. Even though I know you're here to see volcano stuff, there's a lot of different views to share with you guys. And so there's that USGS video. And now we'll move into some of the other photo releases that have been put out. So the USGS has 2 releases of photo sets. One released yesterday from September 10th. And we'll go through some highlights of those ones first. So starting with this is similar to that first video I showed you guys, showing that high fountain in the beginning, right? But this is the fountain now. And note how it's become V-shaped up here. That's really the highest point of lava, right? It seems a little bit bigger than that 50 meters we saw originally. Depends what they were referring to exactly, of course. But here is that main outburst. In this early frame, there's not even an outbreak up here at the base of the crater wall yet. That's how early this actually is. Right? This is going to open up, as we saw in the video. And looking here in the foreground, we actually can see the edge of this flood of lava that's coming across the crater floor here. You see this one patch of very sulfurous rock, a gas vent depositing sulfur compounds there. And it's a good landmark as we move through here. So there is one in the sequence. Here is another. The flow is all the way up to the edge of that thing now. Let's do another. We actually have the first burst of lava from the base of the down drop block wall. And our fountain doesn't look quite as big as before, right, when that happens here. And once again, you see that really nice zigzag pattern there, visible in a photograph here as well. Moving on, well, before I move on from that one is really clear as well. The 82 fissure here early on to show you guys. Okay, moving on, advancing. The upper flow is feeding some volume now. The first fountain is decreasing once again. We have a nice rainbow. So here's a little bit of a zoomed out view, right? So we're looking in, there's that very back area through there, high fountain, the edge of the flow as it's sweeping around. I'll kind of highlight it for you guys. It goes as far as to here. And it's got an edge of some high ground at the down drop block over here as well. Kind of like that. And then there's another channel coming down that down drop block like that. It comes from above. And so that's kind of the shape of it like that at this moment in time. So this thing is marching along in this direction. This one is marching along in this direction as well. This is going that way. All of this is trying to come over here. But note how early this is. This front still even with this patch of lighter ground right in here. We'll advance to the next image the USGS has put out for us here. There's that patch of light ground. And the flow is all the way down to here now. In the shadow, you can see that flow front. And here is the area where it's going to approach that pit from the southwest vent from June of 2023. Also on here, you can see some of these big cracks, which are just one of the boundaries of this innermost plug of land that seems to float above the lava and rise upwards over time. Right, that's why this part becomes higher, and this edge becomes a deeper trough, almost like a moat around that high center area. So there is that. Let me keep going through some pictures here. We have a zoom in of that flow front there. Pretty cool. Big sheets. It's hard to really share with you guys the scale of the size of this thing. It's something we'll have to get at a little later. And in fact, it's something you actually could see from some of the videos of the sampling. Something maybe we can pull that back again and show you guys what that looks like from ground level, how big those things actually are from the ground. But we'll have some images as well. So from above, here's a view from where that KW camera stands. If you were able to go there as a member of the public, this is what you would see. The USGS are able to go there, and here's what you see from the ground. And it's great to have that view shared with us as well. So that was the first batch released yesterday. There's another batch of images released today. Continue September 11th here. And so let's take some highlights of that. This overflight video from early this morning is showing there is that fissure line kind of like from above. Maybe I can show you a little bit easier. So it goes like that. Right here is two together. It steps over. Comes like this, and a little jog here at the end. I think this may be harder to see if it's so zoomed out, but maybe I can make it clearer for you guys. There's that first line coming like this. There. When you see these two back to back, that's where it steps over, and it comes off in this direction. So you can see by this morning, this entire upper segment was waning already. Now it is noteworthy that in June 2023, we had a off on this side over here at that point in time, and that crack was not active in the initial part of the eruption. The later phase, the lava actually reoccupied that crack because it was the highest point it could come out. In that case, lava was burying all the other vents. They were getting submerged beneath the flood of lava, and so the one that was sticking up above that became the most dominant vent up in here. So we thought that might happen with this uppermost vent here as well. But the truth, thinking about it a little bit further, is that all this area, all the way up to here, this all downdrop block area, is above this pool where the lava is flowing downhill. So really, it could stabilize just as easily in these downdrop block vents here in the center. And that right now appears to be what's happening. We'll have to wait and see if that continues or not. So I know I'm covering a lot here. There's a lot of images and a lot of things, a lot of details. There is that on a ground view of the geologist. Here he is with his metal bucket quenching his sample. And from on the ground, if you were standing there, what it would look like to see these fountains and cones. Give you some idea of the size of the hills that are growing. Looks like they might be 10-ish feet tall, more or less here. And some of these fountains, yeah, maybe it might be a similar 15, 20 feet tall, with occasionally you see bursts like this one. It's hard to tell, but there's material rising all the way up to here. Yeah, not very dense, but it's blasting upwards. At night, you'd see it as like a fireworks show, a spray upwards of glowing bits of rock. Easier to see. Okay, so that's that one sampling video. I'm sorry, image. Another one here on the ground. You see a little bit more easily where the geologist is standing on this old ground. Here's the actual edge of the new flow. You see this crack here. It means this piece of ground he's on has actually been bulged higher, so you can stand at the same elevation and actually reach down without having to be right in his zone of heat. However, given the massive amount of lava, he is using a face shield, because what you experience otherwise is if you can feel and smell your eyebrows melting, like you get little beads on the ends of them, and your hairs will all kind of just start melting from the radiant heat. And he's got this nice aluminum coat on as well to reflect that heat from his torso there. Underneath all that, he's wearing that Nomex flight suit because he got here in a helicopter. So he's pretty well protected all around here. But what I really like to share, once again, is this upper view of what those fissures look like from ground level. This is the best view we'll get of that. Advancing. Another image here of that fissure line. We're kind of looking, the helicopter, they got back in a helicopter, they've just taken off, so we're not at the ground level quite. These ferns are just below and a little bit too blurry, but he's probably lifted off a few tens of feet off the ground, and he's looking across the eruption site. So there is that fissure line going down. As a helicopter swings around, they snap another picture here as well, and then upwards and out from there. So they have included different views of each individual fountain. Not every single one, there's too many, but a few of the ones highlighted here. There's an example of one of those that bursts way upwards with the material visible all the way up here at the top of the photograph. Another one coming up here with a little bit less light and more contrast of the lava itself flowing back into the pit. And what's happening is the lava is shooting out and it's landing on the edge and dripping back in, and that's what's forming this cone. So every time it bursts upwards, it's adding another little layer, and that's how these cones grow over time. At some points, they may become top-heavy and collapse back in, and so they adjust that way as well over time. All right, we're almost through the USGS photos here. There is this last one showing a couple events, one bursting up and the flows that feed from them towards that sampling spot. So pretty immersive photograph here, about as close as you could get, and still be able to get back home at the end of the day there if you have a helicopter waiting for you. So those are the USGS images. There are also images of the new webcam. This is that S2 camera deployed here, and the scientists scoping out that spot, monitoring from that edge of the down drop block for that new installation as well. So those are the observations from the USGS, but as I mentioned earlier, we do have some from the public as well. How's our time going here? Maybe I'll squeeze some of these views from the public in as well. Oh, that's the wrong one. Bring it to here. All right. So quick photo from before bedtime from Hawaiian Acres by Hans Morgan. And there it is, glow in the sky, Milky Way, fantastic image. Yeah, so pretty epic. All these images from the Hawaiʻi Tracker Facebook group that Dana's put out for us as examples. Here is a video that's been put out by Tabitha Lopez, video taken from Kilauea Overlook. Let's see if I can play a little bit of this. What it looked like on our very first night. Higher fountains, more fountains, widespread. Changes really everywhere last night. So tonight it's a little bit more subdued, but that doesn't make it any less amazing. It's still super amazing, and if anything, you can more easily decide where to look because the fountains are more all in one area as opposed to trying to look left and look right and look left and look right, and you end up getting whiplash from trying to look all over the place. So much is happening all across the landscape at one point in time. So there's still plenty to look at, but the fountaining will be focused in one area, and that's what's expected for the view tonight. So pretty cool from last night by Tabitha there. Let's share another one. This is by Yvonne Bauer, longtime contributor and member of our community here. So she's got some images, and this one I think is really cool because she starts off being in that area towards the steam vents towards Volcano House. So this first view of her first view of the eruption is actually showing, this is the edge of the down drop block here. This is one of the big cracks that you see from above in that area of the down drop block, and all you see is a fountain peeking above it. So that initial burst of lava, when the fountains were the highest, this is how high they actually were. So you could see that, and over the course of the day, you might see a little bit less, but occasional spatter reaching above this rim. Mostly what you could see from that area. She does continue around, working her way to the north side of the caldera to get these more expansive views where you can see the full vent in there as well, and fantastic view of the glowing fume as well, and landscape, illuminated vegetation. It's really fantastic. Good job, Yvonne. So she's got a few more, not too many. Some of the views, the overlooks, zooming in on the fountains. There you go. So that's from Yvonne. Now how everyone is contributing on our Tracker Facebook group. This from Andrew Cooper, this video, similar to the one we saw from Tabitha, just showing how anybody can see these and get these views with their cameras. And most often it's a cell phone camera people are just shooting with up there. So really a lot to see. Fantastic images. Go see it if you can.
You know, the cell phone photos have come such a long way with the lava. It's really quite a thing to comment on. Like in 2018, I remember the cell phones, they just, as soon as you photograph the lava, especially at night, it just turned into a blurred mess of orange. Like it could not even begin to adjust to the exposure, the ISO, whatever it is, it couldn't even begin. And now it's like last time we were up there, I was shooting with the S23, and it was just like, wow, this feels totally different. Just in 4 years, 5 years.
Yeah, not to say that everyone is using camera. I'm sure there's people who got better gear. I don't really know what everyone's shooting with. This one is from Ruben Kanui.
Right.
Looks a little bit more zoomed in. Great video regardless. Thanks for everyone for sharing. This might be the first and only time we do the slideshow, this eruption, just to share with you guys how easy things are to see, but we expect to have lots of contributions. So check the group if you want to see more of this imagery. Otherwise, we'll just turn into a slideshow for the next 2 weeks here, and we would like to focus more on the science, but also to share with you guys what you can see, how you can immerse yourself with this process of volcanism, learn about it. Our ultimate mission, of course, is that we can all be better prepared for any potential disaster of lava in communities. So the more we learn about it, the more we talk about it, the more we understand, the more we can help each other come time that lava is once again affecting people. And thankfully, I think it was KITV asking me today, what's the difference between this and 2018? Well, some of the fountains are similar size. The amount of lava can be similar at some points in time, but the real difference is the lack of dread and anxiety, knowing that that's heading towards a whole bunch of houses. So much better to be able to learn from the process and observe what's happening without having that anxiety and worry. That's the perfect situation for us right in here within the pit where it can't escape, it can't go and affect anyone's infrastructure. So that's Ruben's, Mahalo Ruben, Tornado Tim, a couple images of these bursts, fountain bursts and the lava lake movement in the background there. And then let's just do one last one here from Dark Horse Photography. There is that full fissure line viewed from the north once again. So lots of observations there. That is, I think, enough to show for now. Things are expected to change here. Let me pull the live video back up for you guys here, but things are expected to continue to change over the next few days. Often the most dramatic change happens in this first 24 hours, which is why we like to bring this version of the update when this activity renews. However, none of this seems very, what's the word, right? Nothing is very threatening to us, right? So now that we can once again reestablish that lava is still contained in the caldera, not moving in the rift zones, it's fantastic to see. We've laid out the patterns and the issues. We will likely come back to you guys with our next update on a regular day on Thursday, unless there's some reason to jump in ahead of time before then. So we're not ending quite yet, but just to lay out the schedule there and kind of lay things out. We'll look at the changes for the full first week later on in a week there. So Dane, I think I have babbled on plenty here. Right. I should give it a shot now.
Well, there's a bunch of questions that we have in chat, but we can get to those in a minute. I'd like to thank Dano and Carrie for coming by and helping with the sign language interpretation, being able to provide a more experienced interpretation of like the different dynamics that we end up covering with the volcanoes that might be outside of most interpreters' experience. So we appreciate them. We think they're doing a great job. Also want to just shout out HVERI, the Hawaii Volcano Education and Resilience Institute website, hvery.org. And that is where we also take donations. You can do either a single-time donation or a reoccurring donation there, a monthly one. And that really does help us out and be able to continue operations on the back end, with particularly in the information sharing aspect of everything, getting this information out there like we are now, and then our resilience hubs and our digital resilience frameworks and program that we're working on. It's a whole bunch of different stuff, but yeah, that's kind of what we have going, and your support goes a long way. We appreciate that. Want to shout out some super chats that we had come through. One was from Skagit Ed. He said, Dan and Phil, mahalo for all the hard work and sharing the science. That was a $20 super chat. Another $20 super chat from Christy. He says, thank you, gentlemen, for your time and knowledge to keep us informed or keep us updated. And we had $5 from Natasha, who asks a question. And we'll do that one we'll do that one first in the questions when we get to that. And then a $30 super chat from Earthquake Sim It says Mahalo H. And Mahalo, definitely check them out too. They do some interesting models if you're looking into earthquakes modeling and stuff along those lines and simulations. All right. Well, that gets us through the donations and stuff along those lines. We do have some questions lined up, Phil, if you want to take those on.
Yeah, let's have some discussion here.
So the first one, let's do Natasha's. Says, is the vent the same location as the initial lava lake? Is it inside the lava lake, the vent, essentially?
Yeah. So the initial vents seem to come through the lava lake and near the edge of the lava lake, and since then those vents are no longer breaking through the lava lake. The vents that are still active now are on a down drop block, and thus it's unclear whether lava is still coming into the lava lake from below or not.
All right. So this is one of my questions. So we did get a measurement yesterday from USGS, like right after the thing erupted, like what, an hour, 2 hours afterwards. So when it was at that height, and we got a measurement of that rough 100,000 tons SO2 per day, which was higher than, the previous eruptions, essentially. Now, my question is was it actually more vigorous in terms of emissions or, the volume, anything along those lines? Or was this more something to do with the timing of the reading, and the reading being, like 2 hours off of the initial to being 12 hours off of the initial, or something along those lines, where they just missed that 100,000 on the previous eruptions, but it was there in the initial stages, but they caught it this time.
It could be, yeah. Two things. One, it's preliminary, so I really hesitate to go on 100,000 until we know exactly.
We've seen how that
eruption in
changes.
June was 75,000. 75,000 is about 100,000. It could be exactly the same as June. So we can't tell now if it's more than June, less than June. It might be about the same as June, right? And June was similarly gassy. In fact, I think I didn't show the video today, but we saw the onset of the June eruption seem to be more gassy than this one, in fact, with more floods of lava, almost a lava tsunami coming across the crater floor that we talked about. We did not see that this time. So,
and we didn't have that drop down either. But I guess that was a few days into the thing, wasn't it? Last eruption.
Yeah.
So we still might, but as of right now, we haven't.
Right. So yeah, those are differences. Yeah.
All right. So Richards asks, will the eruption stop when the deflation stops?
No. We've seen before in both previous eruptions, actually most of the eruptions we've had in the summit in the last 4 years here, that the deflation will stop before the lava stops. So it's like the nozzle starts constricting and less lava goes through it. And when not enough can get through there, it starts backing up in the reservoir underground. So it starts to inflate, even as lava is still coming out of the ground. But once you see that, then you know that you've reached that threshold where something's happening with the exit pathway, where not all the lava can get out as well as it did before. Yeah, but short answer, no, not necessarily. The the tilt meter can indicate other processes besides deflation, inflation. Let's say that a crack opened, into some other part of the caldera area. Then you might have a deflation in one place and inflation in the other, and it might be kind of funny like that, more localized. But that's all speculative. The simple answer is no. The deflation doesn't tell you that it's over. It tells you that maybe it's starting to be over, but our eruption that we saw from December 2020, it switched to inflation, I want to say, after about a month, and it went on another 5 months beyond that, or 4 months beyond that. So it can really drag on for a while, or not. Like in June, it only lasted 11 days. It could just not.
All right. I'm going to answer this one real quick. Somebody asked, is there anyone flying drones to get filming? Drone flying is illegal in the park and enforced, so would not recommend. And no,
yes, someone did try to fly one, and they got busted.
Try and fly. Did they get busted? I heard about it last night. I know they were searching for the guy. I didn't know they got him.
Well, let's just say they got him.
Okay, somebody got tased. No, I'm kidding. All right, so Dennis asks, I got a great question here. The past 3 eruptions featured 0.25 to 0.3 meters of inflation before the eruption. Is that significant or just coincidence? I think that particular amount of inflation potentially.
Yeah, it's interesting because it's it's all within the same area, right? So I should just say that this is all discussion. Like I don't have the answers. It's more about what we can how we can get to it there, right? But one thing that I mentioned previously was the earthquakes. How the earthquakes have built to higher and higher levels prior to each eruption over the last year here. So it does seem like the area underground is strengthening to some degree as far as its ability to host a larger number of earthquakes. As far as it actually tilting upwards, it seems like it's more or less a similar threshold, but the actual baseline seems to vary. So it's something, to me, I don't know how to describe this, but my intuition says it's something about how the blocks are all separate and it can kind of wiggle independently, right? So there's like some amount that they actually can wiggle and adjust that bulge from below before they can't, and it just crack and the lava comes up and through, right? So that might be more to do with like the strength of the rock, perhaps, in the area than like a full systematic picture, like the earthquakes might be giving you more of an idea of that, since they're actually changing over time and the inflation is not. But it is a great question, Dennis. Like I said, I don't have a straight answer for you. I don't think it's just a coincidence. I think that it is telling you something more about the properties of the system, that it's able to pressurize about that much before it actually can pop, right? But I would also say it's likely more complex than that. Likely probably matters where and how much. And it's not just, we're talking about tilt meters having like one data point here, 1 point here, and 1 point there, for example. But really, the whole thing is a canvas, and the whole area can be bulging unevenly. So those are some caveats I'll throw in as well to the discussion.
All right. Next question is from JC. Asks, it had been uplifting prior to the eruption. Was there something specific that set it off?
Ultimately, the eruption was set off by too much magma underground that couldn't fit. That also led to the earthquakes. That also led to the swelling. So the common cause is too much magma. And everything we see is all the symptoms of that.
And even that a little bit further is, we've been talking about this since before Mauna Loa, that the magma supply from depth seems to be above average. A high amount. We have a high amount of lava coming into the volcanoes.
It's hard to know what average is, but I've been calling it very, very healthy. Very healthy supply of magma.
Very healthy supply, right? It doesn't have a lack of magma under there.
Yeah, and those of you guys watching earthquakes under Pahala for the last many years, that's likely associated with that as well. So the actual input from below is, we believe, very healthy, and it's causing all those earthquakes, and possibly both volcanoes erupted at the same time last year. That takes something unique.
Right. All right. Next question is from Facebook. Dave asks, is there a rhyme or reason why the eruptions had happened in different locations within the caldera? As because it seemed the area of weakness or passive least resistance in prior eruptions would still be the area of weakness, or is it easier pathways for magma to move?
Yeah, that's a great question as well. It's hard to tell. One thing that I wanted to point out with those earthquakes was that the whole system seems to be strengthening, right? So that's telling you that the areas that were weak for one eruption may not be the same areas. They may not be weak for the next eruption still, because it may have been filled with magma or lava and then kind of welded shut, or at least there's not as much wiggle in there, or something along those lines, right?
Right.
So what we can see is, for example, now, even in a view we have on screen here, we have this crack that goes across the edge of the crater. Is that it right there? It's hard to tell. I think it might be, it might be the bottom here, right? And the crack, our fissure is cutting across it, right? We have a fissure going across 3 different collapse cracks, and our new fissure went across 3 of them. So it actually broke new ground that was in a different direction from those cracks. So what you can say is the ground must have been strong enough there to hold it in everywhere else, including the previous eruption site, to do that. One thing to add is that it really depends on how long you have between your eruptions. If you have an eruption occur and it's just stopped for a couple of days, then it's much easier to reoccupy that pathway than if you're waiting 2 months afterwards and you're given it a chance to really harden and solidify and congeal in there,
Right. All right. Well, I think this might be the last question, unless I see something else in the chat come through. But Billy
I have a list
asks,
too.
you have a list to go through. All right. Billy asks, looks like the big island on the bird-shaped lake basin features are still visible. Is that the old west vent complex still above the new lava?
That's a good question. I think maybe the best view would be the USGS thermal camera. Let me see if I can find that here among these many. Okay, here's a time lapse. Yeah, it does appear like this area of the old west vent complex kind of through here. You can just barely make out the west basin here. But it seems like all that seems to be above lava still, yes.
All right. So what do you got in the question stack?
Well, I had our 2 pineapples Ohana send a list of questions here, and there's a whole bunch of them, so I'm not sure I'll get through all of them here, but I give some of these a shot here. How long will the eruption last? Okay, well, no one knows, but we're guessing similar to the last one. Until we see something different, we're assuming that it's following the June model. My guess, complete guess, is in the order of 1 to 2 weeks. Does inflation deflation have an effect on how long the eruption will last? Not necessarily. The inflation deflation is more of a background process of the magma moving within a reservoir at depth. Inflation deflation is something that's not been definitively tied to any particular process or surface expression. So sometimes it happens, sometimes it doesn't. And anything can happen when it is or isn't happening either way. It's kind of a curiosity. We try to link it together, but it's nothing so simple and obvious that when it starts happening that we see the eruption is going to stop, for example. So you just don't know. It just means that there's movement within the magma reservoir that the surface can detect. Why are there not as many earthquakes now that it's erupting? I think I answered that one already. There's less pressure feeding the earthquakes to the sides, so it's feeding the eruption upwards and outwards. Are the old ponds filled in? No, they're not. We just talked about the West Basin not being filled in here. And we showed earlier that new Southwest Basin from the June eruption had a couple of flows right here come into it, but very far from being filled in as well. What kind of lava is flowing out of the fissures? This is our typical Hawaiian basalt. We don't have any more details on the chemistry yet. That's what we'll get from the USGS collecting samples today. They'll come back to us in a week or 2 or more with the results of that. They can do it pretty quickly if that is their priority. Their lab with UH is something they can turn around chemistry pretty fast, but they may have other priorities as far as measuring and mapping and things like that. Okay. Was this triggered by a seismic event? I think we kind of touched on that one as well a little bit, that there were some earthquakes as a result of the magma filling in below, but it was really the extra magma that caused it to all happen. And the extra magma caused extra earthquakes, and it caused extra tilt, ground tilt, and it caused all the stuff that we have discussed here. Do earthquakes in Russia, Japan, and the Southwest Pacific have an effect on Hawaiian volcanoes? Usually no. Usually no. But if the volcano is ready to go, it's right on the edge of something happening, then the entire island rocking with those distant large earthquakes can trigger it in rare cases. At that point in time, anything could trigger it. A rockfall could trigger it. Anything really, right? But it can be that an earthquake far away is what actually does it. The way I imagine that is like when you have like a bottle of soda pop and it's got the bubbles in it, and they're not all like they're kind of all separated, but then you give the thing a nice big tap and all those bubbles can just use that little energy to coalesce and come upwards and kind of push up. So that's kind of an example like where you can have a bunch of stuff already just sitting in place, and then an earthquake can kind of trigger it to coalesce and induce something to happen. It's got to be right about ready to go anyways. But the easier answer is no, unless you have a very, very, very special case. Which, it can happen, right? We did see reports in the end of the June eruption how there was an earthquake did seem to affect the output of lava from the vent because it was in such a knife edge balance of erupting and not erupting that might have actually triggered something to change. So that's an example of it actually happening. Let's see, how many more do I want to do here? Because he sent me quite a long list here. Will the fissure spread to the other side of the caldera? I doubt it. I think it's kind of established, stabilized for now. We see more fissures in the downdropped area. Same answer. I think it's like stabilized for now. How long will it take to fill the caldera? Question we hear over and over again. It all depends on the eruption rate. However, even at the largest rates we've seen from the eruptions of this volcano in the last 5 years, 4 years, it would still take many years to fill it all the way up to the main caldera floor and further to spill out of the caldera beyond that. And if that were to happen, it would go into the national park where there are no houses or residential areas. So that's why it's such a great place for the lava to be, and why really we don't worry about it filling, because it's going to be so long on the horizon that every time we try to guess, it might take this long, it might take that long. It's always with the caveat of if something doesn't change with eruption first. So that's a primary factor. How long does it actually last? If it lasts 11 days, it does a lot less work than if it lasts 111 days. And that's mostly what determines how long it takes to fill, is how often is it putting lava into the ground, more so than the rate of it. Yeah, so that is the answer to that. Years until it fills entirely. And could we feel the heat from the volcano where we were today? So we were in the northern edge of the caldera. We could not feel the heat. The wind was at our backs. That's where you like it to be. No fog in our face either. However, I did speak to some people who were at the Kīlauea overlook last night before it closed. They noted that the fog was not terrible there, but it did look threatening. And in fact, they noted as well that while standing on that edge of the overlook, they could feel the heat from the fissures blowing over them. So that indicates that they're a little bit more downwind as well. But so there are people who did feel the heat of this eruption from the caldera rim, but it was in the south side before it closed, and it was not me where I was today on the north side. Let's see here. Is the area around Sandhill magma storage that fuels the caldera eruptions? So yes, there are multiple chambers of magma in the caldera, shallow under the center of the pit, and a deeper one offset to the south that's much larger. So they're both in play. We've discussed that previously, and we'll dive into that further in times ahead, but that's the short answer. Why do the birds still fly around a caldera during an eruption? Your guess is as good as mine on that. They really don't want to leave home. They like to live in the cliffs, and I guess the heat's not enough. The gas is not enough to displace them, because we do see them pretty commonly. And yeah, it is always striking and amazing to see that happen. I think that one last one here. Let's see. When lava goes into the ocean, does it damage life around where it enters? Yes is the answer. If there's a reef, it'll bury the reef. If there's fish in the reef, it'll cook those fish, and you'll see them floating on the surface after that happens. Last time we had lava in the ocean was 2018. And we saw that. Dane, all you. That's my last question.
I was going to say, even if that doesn't get them, it's the algae bloom will. And that was really the thing that looked like it got the most stuff in 2018. It wasn't really the lava and the heat that got some, but that algae bloom, once it got going and started getting all wide, that really forced the life out of the area. Yeah, that was my read on it.
And just to be clear, what happened there was the lava was pouring down the eastern part of the island down to a depth of, I think, 900 feet. So you put all this hot lava down where the water is very cold, and so you initiated a circulation cell bringing cold, nutrient-rich water from depth to the surface. It all bloomed. You probably had all kinds of life coming in, and then realizing that was all out of balance and dispersing afterwards. I'm not sure who saw what. We have to ask the fishermen maybe what they saw during that time. But we did see the reports from, was it a NASA study perhaps, of the algal blooms as a result of that eruption.
Right. All right. Well, I think that does it for me. We've tried to get through a bunch of the questions. I know there's probably more out there, but we'll be back on Thursday to try again on those front. And guys, don't be shy about sending these to USGS as well. They love questions. They love these things. You know, no, I'm just kidding. But
Yeah. Ask HVO at usgs.gov.
yeah, that's what they're there for too. I mean, we shouldn't have all the fun on those types of things.
If they're too busy, yeah, throw them to us. But yeah, hit them up.
Hit them up.
Yeah.
Yep. All right. Well, I think that does it. Back on Thursday, 5 p.m. Hawaii Standard Time, unless something, big happens, and then we'll go live and cover that. Don't really expect it at this point. We got our eruption. It's pretty, it's all about the sites now. And I'm sure there'll be a lava stadium viewing area up there again tonight. Probably traffic is already packed up there, and it'll probably get better once it gets a little bit later. So if you are going to go up there tonight, maybe wait till 9 or 10 if you can. If you're not working super early, try and skip the crowd, because it is kind of a not that much parking for a lot of demand right now up there.
Yeah, it can be hit or miss. There's often a rush around sunset. If you're nearby, sunrise is the best time to go. The emptiest, the quietest, the least wind, the least people. Be prepared for it to be cold, because that's been the case. Occasional drizzle, but really, if you're over Wikahuna, hardly at all. So my experience was that I arrived yesterday at around 7:15, and I just missed the sunset crowd, and someone came in 10 minutes after me and got stuck in traffic for like half an hour. So it's really, you got to get in right at the right time, hit or miss. And if you're willing to park a little bit further away and walk a little further, there are great views all around the area, but you have to walk back to your car at the end as well. So
there is a one other warning that we haven't talked about yet. A lot of people are parking away from their cars. Some are parking at the visitor center and then walking down through the steam vent, the steaming area, the steam bluffs, that walkway. I gotta warn you, you got allergies to wasps, just be careful, because that place is just wasp city walking through there, right?
There are some, yeah.
There are some, and it's just something to be aware of, so you don't show up and be like, "What is this?"
Yeah, they do pretty well and trying to eliminate them, but they are tough and nasty to get rid of. So they are around the Vespa wasps. Yeah. So
yeah.
Okay, we've gone extra long.
Yep. Thanks, Gary.
Extra thank yous. Yeah, an extra thank you to our ASL interpreters, just to give you guys a little insight, because I think it's something that we didn't quite realize at first. A lot of terminology we use talking about volcanoes is very specialized. It doesn't exactly translate. The captions don't get it right. It's something that they are really becoming specialist interpreters for our volcano information here on Hawaii Island. So we're really happy to share in this journey with them, and huge mahalo to you guys. Yeah, once again. Right. So from Hawaiʻi Tracker and HVery, until Thursday, enjoy the eruption. He's Dane DuPont. I'm Philip Ong. Aloha, everybody.